Okay, this is problem number 11 on the trigonometry final review. I want you to first of all notice I've made a change. That shouldn't be negative 5/3. I changed it to negative 3/5. And I think you'll see what I'm talking about when we get into the problem and why this would just never work. So anyway, make that change. I'll try to make the change. I have to edit the document and then remove the document from Canvas and re-upload, so that may be tomorrow or the next day before I get that, but hopefully I'll remember and get that fixed. If not, when you watch this video you'll know the problem's a lot easier to work if you look at it this way. So here's the problem. It says, what is the exact value? Now what they mean by exact value is, don't just take your calculator, take the inverse cosine of negative 3/5 and then take the tangent of that and get some long decimal. They don't want the long decimal, they want an actual value. Now this one actually comes out to a value that you probably could do that in your calculator, but don't count on the one on the test being able to do that. It'll probably give you some crazy irrational value, and what you need to do is say, well, no, that's the square root of 2/3 or something like that. So let's dig into this. I kind of like this problem. It's grown on me over the years, because when you first look at this problem you think, oh my gosh, how do I untangle this thing? How do I make sense out of it? It looks super complicated. And then once you do it, you realize that this may be one of the easiest problems on the test. Okay, so let's break it down. Let's start just like any good math problem. We start on the inside, right, and figure out what are we even talking about here. What is the inverse cosine of this fraction? Well, all of this just represents an angle. It represents an angle on the Cartesian coordinate plane. We'll just call it theta. And it's an angle that just happens to have a cosine, right? The cosine of this angle is negative 3/5 because the inverse cosine returns the angle. Okay, so now we've got something we can start, we can make a picture of this. So let's just draw this out. Let's see. The cosine of this angle is a negative number. That means that the angle has to be either in quadrant 2 or quadrant 3, and we'll see if anything distinguishes that. So we're just going to say this is our theta, or it might be here. Got two different possibilities, at least for now. Maybe it'll stay that way. So let's go ahead and say, well, if the cosine is negative 3/5, then that means that this distance here is negative 3 and this hypotenuse is 5. Okay, well, now we've kind of got a foothold on this problem, because the tangent of this angle, remember this is all just that same angle, the tangent of this angle is just going to be this opposite side over this adjacent side. What is this opposite side? Well, we're going to take 5 squared minus negative 3 squared, and then we're going to take the square root of that, and this is 25 minus 9, 16, and it's 4. So actually it's plus or minus 4, and look at this, we've got a plus 4 up here and a minus 4 down there. Okay, so what is the tangent of this angle? Well, it could be either one of these cases, so let's just talk about both of them. It's either going to be 4/5 if it's this particular angle, or negative 4/5 if it's down here. Now it might be the case that the one on the test only resolves to one quadrant and you have one answer, and that's fine. This one just happens to be a case where depending on which situation you have for the cosine, it could give you either a positive or negative value for the tangent. That's all you got to do on this problem. It's really, once you sort out that, hey, I'm just drawing another one of those pictures and filling in the sides and then working out the trigonometric function, and you realize, well, that's really all it is. And it starts with something that looks super complicated, and then you end up realizing that it's really not that complicated at all. I just need to map it out and find out what the exact value is. And that's all there is to it. That's number 11.